Xinwan X16R debugging tutorial. This teaching video takes aluminum flat plates as an example, and the debug method is generally applicable to other profiles. The differences will be explained in detail. First, put in the materials. Manually pass the plate through the straightener until the bending outlet, ensuring smooth flow. Adjust the height of the material clamp and lock its position. Finally, rotate and adjust the straightener appropriately. When switching other materials, it is necessary to adjust the height of the feeding tray. The adjustment method is to rotate and adjust the hand wheel under the feeding rack. The only height position of the sponge strip is as shown in the video. And the only height position of the triangle head is as shown in the video. The preparation work is completed. The first step is to install the software and drivers. Firstly, insert the U-key and USB drive. Open the computer. Copy the USB file to the desktop. Open the software installation package. Select the language and choose a disk other than the C drive for the installation path. Follow the prompts and click Next to complete the installation. Open the driver installation package and click Next. Note that the driver installation path must be consistent with the software path. Click Next according to the prompts. Select Install this driver software in any way to complete the installation, and close the pop-up window. Run Xinwan automatic extrusion machine. Click on Language in the menu bar. Select the language, and the software installation is complete. Second, Introduction to materials parameters. You can quickly open materials in the general control panel. Built-in multiple materials parameters for selection. Can change operations such as slotting type and front swing angle. Select the height sub-option below the sheet name. Parameters such as actual ply and front and back slotting trip can be changed. Remember to click Save after making changes. You can quickly switch between sheet classification in the Materials Options panel. This tutorial takes aluminum flat plates as an example, so choose AL flat 0.6 and select the corresponding height. Third, Feed adjustment. In the General Control panel, click on Feed Adjustment. Click Start according to the pop-up prompt and make the starting mark at the slot position. Click OK. Wait for the feeding to stop. Then mark the end and click OK. Measure the length between markers according to the pop-up prompt. Click OK and pick length. Click Confirm, click OK, and close the window. Next, perform calibration and fine-tuning. First, make the stop mark. Click on the Step Control Switch panel. Check the step parameter to change it to 2000 mm. Click on Material Forward. Make the end mark, and measure the length between the marks. Click on Tool in the menu bar. Click on Feed Out Inching, and change the feeding length to 2000 mm. Change the peak length. Click Calculate, and note that Calculate can only be clicked once. Click Save, then click OK. Feeding calibration completed. Fourth, Work parameters. In the General Control panel, click on Work params. Find Front Home Offset and click on Front Offset Test. Observe and determine whether the swinging position of the milling cutter is perpendicular to the slotted plate. If it is not perpendicular, click No. Change the front home offset parameter and repeat the test until the milling cutter is perpendicular to the slotting plate. Click Yes. Click OK. On the basis of this numerical value, increase by 180 degrees to back home offset and change the parameters. Home offset debugging is complete. Find depth arrive and try not to change this parameter, but click depth arrive test once and click yes. In-depth debugging completed. Find home offset and click test. Observe and determine if the position of the rotary bending blade is centered at the discharge port. If it is not centered, click no. Change the home offset parameter and repeatedly test it. Until the position of the rotary blade is correct, click yes and click OK. Home offset debugging completed. Find positive idle and click test. Observe and determine whether the right rotating curved blade and the right fixed curved blade are parallel to the discharge port. If they are not parallel, click no. Change the positive idle parameter. Test repeatedly until parallel. Click yes and OK. Find negative idle and click test. Observe and determine whether the left rotating curved blade and the left fixed curved blade are parallel to the discharge port. If they are not parallel, click no. Change the negative idle parameter. Test repeatedly until parallel. Click yes and OK. Debugging completed. Save it. Fifth, adjustment of slotting stroke and depth. In the Material Options panel, click Positive Test. Observe and determine if the slotting is complete. If it is incomplete, change the front slotting trip. The larger the value, the wider the slotting width. Repeat the test until the slotting is complete. Change the back slotting trip to the same parameters as the front, save, and complete the slotting trip debugging. Click on Positive Test. Observe and determine whether the slotting depth is appropriate. If it is not appropriate, change the positive slot base. The larger the value, the deeper the slotting, the smaller the number, and the shallower the slotting. Repeat the test until the groove depth is appropriate. Click on Reverse Test and observe the depth of the groove on the back. Change the reverse slot base and repeatedly test until the depth is appropriate. Debugging of slotting depth completed. Click Save Material and click OK. 6th, Arc Forming Offset Debugging. In the General Control panel, click on Bend Knife Calibration. A pop-up window indicates that there is an illegal slot in the design drawing. Click OK to ignore it, or click View in the menu bar, click Show VG Error, and uncheck it. Note, if debugging is for channel loom, triangle, and other profiles, this step requires changing the mean radius of extrusion of the board to 20 mm in the Materials panel. Click Save Data to close the window. If you are debugging an aluminum flat plate, there is no need to make any changes. Start debugging. Right-click on the workspace and click on Outer Peak to pick up the internal graphic of beading. Right-click on the workspace and click on Confirm Peak. Note that the sheet metal should be sent to the exit of the bending blade before processing. In the Processing Control panel, click the green button and start processing. Wait for the processing to be completed. Observe if the length of the front and rear sections is consistent. If the front section is longer, it indicates that the bending position is delayed. Click on Work Parameters and change the leaf arc offset. The larger the value, the more forward the bending position will be. Click to save. Repeatedly test until the length of the front and rear sections is consistent. The bead arc offset debugging is completed. Now, let's X the arc offset to offset. Pick up the external shape of the beading by picking up the outer peak. Start processing after Conform Peak. Waiting for processing to be completed. Observe if the length of the front and rear sections is consistent. If the tail section is long, it indicates that the bending position is closer to the front. Click on Work Parameters and change X the arc offset settle. The larger the value, the the more backward the bending position will be. Click to save. Repeatedly test until the length of the front and rear sections is consistent. Change the changed mean radius of extrusion back to 25 mm. Click Save Data to close the window. If debugging is on an aluminum flat plate, there is no need to make any changes. Arc offset debugging completed. 7th. Bend knife calibration. In the General Control panel, click on Bend Knife Calibration. Pick the internal graphics of beading in the text box. Note that if channel loom, triangle, and other profiles, this step requires picking up the external graph. Start processing after conform pick. Wait for processing to be completed. Observe the contrast curve, and if it does not match the shape. In the General Control panel, change the positive beading plus. The larger the value, the greater the beading force, and the smaller the value, the smaller the beading force. Repeatedly test until the curvature matches the graph. Right-click on the workspace, click on Clear Pick, then right-click on the workspace again. Click on Inner Pick, and pick the shape. Start processing after conform pick. Waiting for processing to be completed. Observe the contrast curve if it is not consistent with the graph. Change the value of negative beading plus in the same way. Repeatedly test until the curvature matches the graph. Beading adjustment completed. Next, adjust the extruding plus. Outer pick extruding plus graphic. Start processing after conform pick. Observe the contrast curve if it is not consistent with the graph. Change positive extrusion plus. The larger the value, the greater the arc squeezing force, and the smaller the value, the smaller the arc squeezing force. Repeatedly test until the curvature matches the graph. Right-click Inner Peak Graphic. Start processing after conform pick. Observe the contrast curve if it is not consistent with the graph. Change the value of negative extrusion plus in the same way. Repeatedly test until the curvature matches the graph. Bend knife calibration completed. Conventional processing can be performed. Right-click on the workspace and open the graphic. When picking shapes, double-click the starting position to select all shapes. Start processing after conform pick. Xinwan X16R debugging tutorial is over. Thanks for watching.